This is part 2 of 2013 high level question 6. Part 2 of my videos anyway. Part 4 in the questioning. Name the type of acceleration that the space station experiences as it travels in a circular orbit around the Earth. That would be a centripetal or a centripetal if you prefer. Centripetal force. What force or centripetal acceleration? Oops. Then you're asked what force provides this acceleration. That would be the gravitational force. The force that is due to gravity. Next bit. Calculate the attractive force between the Earth and the space station. Okay, so we don't know the mass of the Earth, so we can't use Newton's thing. If you look ahead, that's actually the next question. So we need something else that can help us here. Okay, so what we're going working with is the centripetal force calculation, which is m or squared, m or omega squared, m or omega squared. Okay, so I know the mass of the space station. It's given at the bottom of the question. 4.5 by 10 to the 5 kgs. My I just used it a minute ago. It's the 4.13 by 10 to the 5 of the space station's altitude plus the 6.37 by 10 to the 6 of the Earth's radius. And then my angular velocity, I just worked it out a second ago. Where's that gone? 1.128 by 10 to the negative 3 to be squared. Okay, so 4.5 by 10 to the 5 multiplied by 4.13 by 10 to the 5 plus 6.37 by 10 to the 6 multiplied by 1.128 by 10 to the negative 3 to be squared. Gives me an answer of 388,376.1.302 newtons. Okay, that's my force due to gravity, the gravitational force. The next bit is to calculate the mass of the Earth. Okay, so I know my force due to gravity. I can find out my gravitational constant from the log tables. I need to know the mass of the Earth. I know the mass of the ISS. And then dividing that by the distance between them squared. Okay, so rearranging this, the mass of the Earth is F or squared over G ISS. Okay, so there's my answer. I just got that 388,376.1.302 newtons. I don't have that ready now. I need to find big G. The radius, anyway, I've been working with it a few times already. It's to the radius to the center of the Earth. 6.37 by 10 to the 6. That's got to be squared in a second. Now, work for me, Google. Okay, the universal gravitational constant is, oh come on, gravitational constant is what Wikipedia is telling me that I should have been pronouncing it the whole time. 6.674 by 10 to the negative 11. And then the mass of the space station, what did we say that was a second ago? 4.5 by 10 to the 5 kgs. Okay.